Hey, welcome to this hands-on guide on LoRa. This is video 5, this is hands-on 2.2, which focuses on sending motion data. So here is a reminder of the agenda of this guide. So in the previous videos, we first had hands-on 1, which focused on setting up a basic LoRa network. This involved configuring the gateway, the end node, and the dashboard. And then we start hands-on 2. We had part 1, which where we set up the environmental shield. So this is the board we're using, a nuclear board and a IKS01A2 shield. And we could see some environmental data on our dashboard. And now part 5 is going to be sending motion data. Um, so this is the purpose of the video. We're going to acquire motion data and send it over LoRa. So as I mentioned, we previously set up this LoRa network with the end node, the gateway, the network server, and the dashboard. Here, what's gonna change is that we're gonna modify the code to actually send motion data instead of the environmental data. So for instance, we will send the acceleration in all 3 axes. And we will also modify the dashboard so that it displays the acceleration. So actually it will display the acceleration and the temperature. Okay, um, so I'm gonna start by going through all the slides so that you have an idea of what we're gonna do. And then after that, we will redo everything slowly together. So the first step is going to be to to create a new project, so WL Lab 3, which will be building on to WL Lab 2. And as we did in the previous video, instead of creating a project from scratch, we are going to be renaming the previous project. So there is a bit of a trick to do that. We'll do this. Okay, import the project. So all of that is about importing the project. And then we will move into actually modifying the code, and everything we're going to do today, like in this video, is going to be through code. We won't be using CubeMX anymore, and this will force us to really dig into what's being done. So actually what we will um, look for are is everything that was done for the environmental data. So how was everything initialized and how was everything, all the data acquired. And we want to copy all of these functions and do the same thing for motion. So for example, here we will start with the initialization, and we will create this function sensor init, so motion sensor init, which will initialize the motion sensors. So there's a bunch of modifications to do. We will do it together. Then once we've created that function, we will need to call that function somewhere, and this will be done here. So you can see here on line 122, we had the environmental initialization, so the initialization of the environmental sensors, and that's where we're going to put our new function. Then we will need to modify our code to read the motion data. So we will create a new function called motion sensor read, which reads the motion data. Okay. So again, this is based on the environmental sensor read function, which was already implemented. And there's also a bunch of things we have to do here, and we'll do it together. We then have, of course, to add this read function in the code. And yeah, here we will have a look at how the payload, so app data, how is app data, the payload that's being sent through LoRa, how is it made? And yeah, we'll have a bit of a look at that. And of course, so the main issue we'll have is that the payload for LoRa in Australia at least is only 10 bytes, and these 10 bytes that we see at the bottom, they don't allow us to send both environmental data and motion data. So we will have to have a variable here, data type, which we will have to set. And depending on the value of this variable, the board will either send environmental data or motion data. So this is what we're doing here. Finally, we will load the code on the board, and then we will have to modify our dashboard. So you actually only have to open the dashboard I'm providing, so it's fairly easy. So okay, we're gonna import the dashboard, delete the previous one. This is a quick explanation of what's new in the dashboard. So okay, there is a data input, there is a data processing, and all these blue things are everything that's being displayed on the dashboard. So all the inputs and outputs. And yes, I did add a note about EUE test. So in the previous hands-on, we had an issue where if we had multiple endnodes, we had no way of filtering the data that was displayed on the dashboard. Now we will have a way to do that. We will also have to configure the Laureate inputs, the Laureate uplink. So yet again, we will go back on laureate.io on our account, and we have to get the WebSocket address and copy that onto the Laureate uplink. So we've done this before, okay, in the previous hands-on. Then, so this is what I was referring to regarding the EUI filter. And once everything is done, we will deploy, and let's move that. We'll deploy, and this is what we will see, right? So we will have this dashboard. We enter our device EUI here. Then we will start by seeing data here. So on the environmental side, this is because the dashboard will be expecting environmental data, but the board will be sending motion data. So that's why the data we are observing is rubbish. Okay, but then by toggling this switch here, we actually tell the dashboard, wait, we are actually displaying motion data here. And by doing so, we end up with this, and we can see here that we have the gravity along the z-axis. And that will be it. That will be the end of the hands-on. We will have motion data flowing from the STM32WL to the dashboard. And actually, so we will look at that later, but yeah, the next steps then will be downlink communication, but that will be in a separate video. Anyways, now what we're gonna do is actually walk through all the steps together and slowly, and see if it works. So the first step was to create a new project. So we did that in the previous video, but basically we have to rename here, change the name to lab 3. Then even though we renamed the project, it is still in a file that is named WL lab 2, which we will actually rename in the file explorer. This will lead to CubeIDE not knowing what the project is, so we will have to delete that project and re-import it. Let's do it. So first of all, I'm gonna go here, right click, clean. Okay. Then I'm going to go right here. Okay. And take this file, and I will copy it, save it somewhere for later. Okay. So put that on my website. Okay. Cool. Now on CubeIDE, right click, rename WL3. I keep this checked. I press OK. Okay, so the project has been renamed, but it is still in a repertory which has the old name. So I have to open, so I go in my workspace, right? C user, your name, CubeIDE workspace, and I right click, rename lab 3. Okay. Now, if I go back on Cube IDE, the issue I have is that Cube IDE doesn't actually know what the project is anymore. So I have to delete the project. Okay, now it's telling me, oh, I don't know what the project is. It's fine. Just press continue and re-import the project. Directory tech. All right, so I'm importing lab3 from my repository. And that's it. We have a brand new project which we can now modify and which has the correct name, but which also has all the modifications we had made in the previous hands-on. We're now going to move on to the next step, which is to implement the initialization of the motion sensors. Okay. So we are going to create this function, motion sensors init, which does a few things. So it initializes the LSM6DSL, it enables the sensors, and then it gets the capabilities. You may be wondering, okay, how did I know that I had to create such a function doing these things? And really, the answer is that I copied what was done for the environmental data. So I will show you, okay? For this function, right, you have multiple things in there. For example, you have the LSM6DSL-0, which has to be initialized to 0, and this is linked to these functions, but basically the LSM6DSL, it can work in different ways. And depending on the value you set for LSM6 DSL, it will be initialized in different ways, but it's just a detail, okay? Okay, then motion capabilities has to be enabled. You of course have to declare the function, and also we will need a .h file, the motion sensors, which is one of the BSP file that was added by the Xcube MEMS package that we used in the previous hands-on. Okay, hands-on 2.1. So let's do it. Let's do it. So let's go in system sensors.c. Okay. Okay. And if I go to line 269, 269. Okay, so I don't have line 269 yet because I have to create it. Here you see on line 206, you have that function, environmental sensor init. And really what I'm doing here is I'm copying this function, because here you see they first initialize the sensors. So they initialize the HTS221 and then they initialize the LPS22HB. Then they enable the sensors, HTS and LPS, and then they get the capabilities. And if I show you the function again, this is exactly what we're doing. We're initializing, enabling, and getting the capabilities, okay? So let's create that function here. So see how I'm creating the function within a user code section. Yeah, you always you wanna try to do your modifications in user code sections in case you would have to regenerate your code with CubeMX. Although we already have some modifications in our code which would be erased if we were to regenerate, so we would probably not do that. But in any case, when you want to do this, what you can do is you can go on my website and you will find all the project files. So instead of struggling and typing everything, you can just copy and paste the code snippets. Okay. So motion sensor init, paste. So motion sensor init, I initialize, I enable, and I get the capabilities. This variable here, we can try and see if we find the answer, but instance, there is a switch case on the instance here, right? And case 0 is here. Yeah, so I think this sensor can it's both an accelerometer and also a magnetometer, and so depending on the case, it will not necessarily initialize the whole thing, but in our case, it's initializing everything. I think it doesn't matter. Okay, if you want to look into it, it doesn't matter. Okay, the other modifications we had to make were to declare this function, right? So I'm gonna copy that, and then gonna go line open declaration and line 91 here. Void. Oh yeah, and of course I need to comment edit UG edit. So you can find all the modifications I make by just searching UG, and you will find all my modifications. The next step then is to add 1.h 109. So here I only have to add this IKS01A2 motion sensors.h. Yet again, you may be wondering, how did I know I had to add this? And the answer is that if you go up, they add the AKS01A2 environmental sensors. Okay, so I really just copied, what they were doing and create anything here. And that's the whole point, this is why ST provides examples in library. It's so that we don't have to do it, so it's great. Okay, so I did this, I have to do this now, and this as well. LSM, so in system sensor.h, line 65. Okay, awesome. The last one is in system sensor.c, line 156. So see what I'm doing now, it's called auto-completion. You have to press Control and space. So AKS, motion, sensors, capabilities. Very good. So that's all the modifications we had to make for that one. And so we end up with this function here, which we have to call somewhere. So in sensor init, which is called in system app init, we have to apply these changes. So Control H system app.c. Okay, line 1, 2, 3. So here we have environmental sensor in it. And so I want to add the functions we just created, which is motion sensor in it. Again, control space for auto completion. We're done with initializing the sensors. And so the next step is to create a function that will actually read the data from the sensor. Okay. So we have to create this function called motion sensors read. Yet again, I created this function based on environmental sensor read, which was already implemented. And so all we have to do is to use this function here, which will actually get the data. And then we take that data, which was stored in a motion axis, and I will store it in sensor data. So motion axis is only used for the motion data, whereas sensor data is a table with everything in it, and that's actually what we see here. Okay, so sensor data is of type sensor underscore t, and sensor underscore t is a I think it's a structure. Yeah, type def struct. Which has many attributes, including the pressure, the temperature, the humidity, which we used in the previous hands-on. But now we are actually adding 3 attributes for the acceleration on the X, Y, and Z axis. And that's it, really. Then we also have to initialize this thing, but it's pretty minor. So let's do it. So in system sensor.c, sensors.c, I'm gonna add this on at the very end, tag 281, and I will just copy it from the example, which again you can get on my website. Okay. Then so we have to declare that function. So we'll take that, tac, and then I will go into system sensors.h, and I think it was on line 93 or something. Yeah, here. Then the next step is motion axis, so system sensor.c. We have this function here, right? And if I go in this function here, I see that this is the type I need, right? So I copy that, and I need to declare this somewhere. So I'm gonna do it line 157. Tac, tac, tac. Okay. Then I want to copy that name, 157. Edit UG. Edit this. Save. And so the last thing is if I go here, sensor data, right click, open declaration, then sensor underscore T, open declaration. So this is where the type is declared, and it's saying here, okay, sensor type has these attributes and it doesn't have anything for the acceleration. So I'm just gonna add them. Okay, X, Y, Z. Now that we have that function, we have to call it somewhere. So I'm gonna go in, oops, I'm gonna go in sensor.c, right? Copy this. And I will call this function in LoRa app.c. Tac, LoRa app.c. So in LoRa app.c is like one of the most interesting files to read. It's really nice because you have two very important functions, one of which is Centex Data. And what Centex Data does is that it's the function that's called every 10 seconds, and that creates the payload that's being sent over LoRa. Then also you have on Eric's data, which is the function that's called every time you receive something. We'll actually touch at this function in the next hands-on on downlink communication. But anyways, coming back to Centex data, we have to modify this function so that somewhere it actually reads the motion data. But first we have to understand what's happening. So here, if we look at this function, environmental sensor read, this is where the environmental data is being acquired. Once this data is acquired, it's put in sensor data, and then it is separated in a number of variables like temperature, pressure, humidity. And then later on, in this part of the function, creating the payload. And the payload is in app data, which length depends on the region. So if you are in Australia or in the US or in Asia Pacific or something, it's 10 bytes. If you are anywhere else, and there are many regions, you have more bytes. It's because every region has a different LoRa spec. But I'm in Australia, so I'm worrying about the Australian payload. And so here we're seeing that before we make any modifications, the pressure is here, the temperature is here, and the humidity is here. And so if you make a table out of that, this is the payload. So it's 10 bytes of data, and you have first the LED state, the pressure, the temperature, and the humidity. And so what we want is to change that payload so that we have the acceleration in all three axes. And well, you can see that we are not able to put the acceleration and the environmental data in the payload. Okay, so in order to to change this, what we will do is we will add a variable which we'll call data type, and then we will add a condition if data type is motion, then we acquire motion data and we fill in app data, the payload, with motion data. Otherwise, if we need environmental data, then we leave the function as is. And therefore, this is where it's going to happen. Here in this user section, this is where we're going to add our code. This is the user code section I was showing. Um, if data type motion, blah, 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 blah. So look into it. I'm just going to copy the code for now. And really, it's not complicated. It's really simple. And be careful. Here we have a parenthesis or whatever it's called, and we have to close it here. Okay, final look. So if data type is data type motion, we acquire the data. This is the function we created, and then in the app data we put x, y, z, and here we just put 0. Okay. And if else, so if data type is not data type motion but is data type environmental, then we're doing what we were doing before. Then of course, this variable here, data type, has to be initialized, and so we are gonna do this now. Line 72. Okay, and that's it. That is all the modifications we had to make. So make sure you've saved everything and then connect your board through USB. Right click on your project and debug. Oh pétard. What have I done? That's it. Sorry guys. Um, mm, mm, mm. Okay, so this happens sometimes. You debug and for some reason it doesn't debug. So just do it again. Like it's built the code, but it hasn't actually debugged it. Okay, so TerraTerm, I'm still connected. My setup is 115 baud, and terminal, I have auto here. Okay. Awesome. So I'm seeing something, and it's joining the network. So that's awesome. However, if I open my dashboard, not only am I seeing rubbish, but also I can't visualize motion data. So we have to import a new dashboard called 7WL simple dashboard uplink only with motion. Okay. Okay, so if you go on truestepbystep.com/LoRa, which is my website, and so for each, that's where you will find the guides associated with each of the video. Here are all the guides. You will also find the projects here and the dashboards. So go in Cube Monitor, here, import, select, and I want to select this one. Okay, V2, I've done some minor changes. Okay, and then I want to close this one. So this is what we imported. So here we have the data input with the laureate uplink node, which we configured in the previous lab. We have to do it again. Okay. Then there is the data processing part, which embeds a EUI test. So I can actually show you how it works. So it's a function that will look into the data. So okay, this is one data, for example. You have a payload, and associated to that payload, you have an attribute which is the EUI. Okay, in my case, that's my EUI. So here, what I'm saying is, I'm saying look into the data and check if the EUI is the same as the one that is here in this box. And this box is actually initialized with this number. So here it is important that you actually configure your EUI, because when you deploy, let's do it, when you deploy, you're gonna have it here. So if you don't change it, in here, every time you're going to deploy, you're gonna have my EUI, which is a bit awkward. Okay, so just change it, and then every time you deploy, you will have the correct EUI here, and only data coming from that EUI will be displayed on the dashboard, which is very important if you have many devices. Okay. LoRa uplink, I have to change that. So you have to go on LoRa. You go into outputs, and you copy this link as was done before. So you can see here that every time I import a new dashboard, it re-imports the address, which is a bit annoying. But in any case, yeah, it doesn't really make a difference. Okay, done. Deploy. Connected. So now if I look at my dashboard, this is what I have. And as you can see, the data that we are observing is not correct, right? I mean, there is something odd here. And actually, that's normal, because if we go back to app.c, when we declared data type, we initialized it to data type motion. And what that means is that right now, our board sends motion data. So if we try to display environmental data on our dashboard, it will receive the data and decode it in the wrong way, which is why it doesn't work. You have to understand that in the payload that we're sending, this one, there is no information about the type of data we're sending, because we're so limited. So that you have to tell the dashboard what data it is expecting. And so, for instance, if I click here, I'm telling the dashboard, look, you have to decode the data using the motion data decode block. Okay. And so now that's what I have. So look, I have my board here, right? And if I rotate it, see, now the acceleration is on the x-axis. So the gravity is always going down, obviously, sorry. So the y-axis is here on the board. If I rotate the board now, on the y-axis, which is here, there is no acceleration anymore, because the acceleration is here. And therefore, this is why you now have 0 on the x-axis, on the y-axis. Now we know the z-axis is here, and so the x-axis would be this way. So if I rotate the board, I should have, right, -10 on the x-axis, and now I should have 10. See, so it's working fairly well. I think this is more like it's better way. Motion data is better to demonstrate than environmental data. Okay, so in conclusion, we now have a system, a network, where we are able to stream motion and environmental data from our end node to a dashboard, and it's working fairly well. The next step then is going to be to try and tell the end node what data it should send, because we would like to be able to select between environmental and motion data. And so one way to do that, I mean, the way to do that is to set up downlink communication, and that will be the final hands-on, which we will cover in the next video. Thanks.